In this video, we're going to factor a trinomial where the coefficient of x squared a is not equal to 1. So we have the example 3y squared minus y minus 4. We'll first go ahead and demonstrate the trial and error method, which basically states that I'm going to set up my two binomials, and I'm going to put the factors of 3 into their locations. Now this is a prime number, so that makes this part a little bit easier. I know that 3 times 1 is 3, so my first two numbers, 3y times y equals 3y squared. The second thing I'm going to do is I'm going to take the 4. Now this is where trial and error comes in. So I have multiple factors of 4. So for example, I could put in 2 and 2. Now because it ends in minus 4, one of these has to be a plus and one of these has to be a minus. So I'll go ahead and trial it like that. Now when I multiply it out, my first terms of course become 3y squared. My last term becomes minus 4. When I put together the middle terms, I get 2y positive minus 6y. And those two together do not equal negative y. So I'm going to go and try again. So again, I'm going to start with my parentheses. I start with the prime number, 3y times y. So I have a limited choices of where those go. Now 2 and 2 are the same factor, so I don't really have anything I can switch there, but I can try, say, 4 and 1. So let's go ahead and try 4 and 1. So since it's minus 4, I know the difference between my center numbers should be minus 1. This looks a little bit closer. So I'm going to try minus 4 plus 1. Again, my first two terms are still going to get me 3y squared. Negative 4 times 1 is still going to get me negative 4. But now in the middle, I have minus 4y, which comes from multiplying these together, plus 3y, which comes from multiplying the outsides together. Now that I put them together, I can go, okay, negative 4y plus 3y, correct, is minus y. So the correct factoring for this problem was 3y minus 4 times y plus 1. Now, there's another method for factoring trinomials called the grouping method. And this comes from our factor by grouping when we have 4 terms. So I can set up this problem with 4 terms by taking the original puzzle that I would use. I'm going to take the first and last numbers. So 3 times 4 is 12. It's actually negative 12 because it's negative 4. And because I have a minus sign here at the last term, I'm looking for two numbers that multiply to be negative 12, but that whose difference is going to be equal to 1, or in this case, minus 1. So basically what I'm looking for is I say, okay, well I know 3 times 4 is 12. And I know that if I take 3 minus 4, I'll get negative 1. So these are going to be my two middle terms, and it doesn't matter which way I place them in my factor by grouping, I'll still end up factoring out to the same problem. So I'm going to go ahead and put the 3y squared, and I'm going to put the positive 3y here, followed it by the minus 4y, and that with the end term of minus 4. So factor by grouping says group them into pairs of 2. So there's my first pair. Also by factor by grouping, if this is a minus sign here, this minus is going to go with the number 4. So it becomes negative 4. So I just basically make my subtraction into adding the opposite. So now I can go ahead and just use factor by grouping. So the first one, the common factors are 3y. That leaves me with y plus 1. Now in order to get a plus sign for this last negative 4 means I'm going to have to factor out a negative 4. So that is positive 1, and negative 4 divided by negative 4 is positive 1. So now I have my common GCF of y plus 1. So that's one of my two factors. And I have what's left over in the front, which is 3y minus 4 in parentheses. So those two multiplied together. And no, it does not matter which way I write them, because remember, multiplication is commutative. I could have written this with the y plus 1 first, multiplied following by 3y minus 4.